Hello everyone, this is Mr. Muhammed Azeez. I'm a math teacher. Welcome back to another tutorial. In this tutorial I'm going to explain chapter 1 of grade 10 mathematics. I'm going to use this booklet that I made. So let's just begin. Chapter 1 begins with numbers. There are many types of numbers. The first one is natural numbers, that consists of numbers 1, 2, 3, 4, 5. These are natural numbers. Then we have whole numbers. It's the same as natural numbers except it has 0, while natural numbers doesn't have 0. After this we have integer numbers. Integer numbers is all positive whole numbers, negative numbers, and 0. Integers doesn't have any point or fraction. After this we have rational numbers. Any number that we could write as fraction is a rational. This means even the whole numbers, like for example 5 could be written as 5/1. This makes 5 a rational number. The symbol of rational number is Q. There is an example. 2 we can write it as 2/1, so 2 is a rational number. 3.5 is a decimal number. We can write 3.5 as 7/2. This means 3.5 or 7/2 is a rational number. Another example we have here, 4.7 repeating. If you see a repeating decimal, this is a rational number because repeating decimals could be written as fraction. This is mixed number, and we know how to make mixed number fraction. Multiply these two, add the result, then it will be 43/9. Then any number that we can write it as fraction is rational. This makes every repeating decimal rational. Number 5 is important, irrational numbers. Irrational numbers are the numbers that we cannot write it as fraction. In other words, irrational numbers have the decimal part goes on forever, and in the decimal places, like a bunch of random numbers, there's no relation between them, it's not repeating, so it is irrational. For example, pi, we know pi as 3.14, but pi is not just 3.14. It has the decimal places going on forever and the decimal places are random. Then this makes pi an irrational number. Any other calculation related to pi is also irrational. For example, pi plus 1, 2 pi plus 1, 3 pi minus 5 all over 10. Any other calculation related to pi or related to any other known irrational, the result as one number is irrational. Square root of any number which is not a perfect square number is always irrational. Square root of 9 is equal to 3. This is rational. But square root of 10, since 10 is not a perfect square number, this is irrational. After this we have real numbers. Real numbers is a very big set of numbers that covers all rational and irrational together. When I say rational, I mean rational contains integers, whole numbers, natural numbers. So real numbers contains all the other sets of numbers that we can represent on a number line. And these are not the only types of numbers. There's another set of numbers that it's only for your information. Is called complex numbers. Complex numbers are the numbers that are not real, that does not have a real value, that we cannot put them on number line. Then if we demonstrate the number set, real number containing all the numbers, then inside real number there are irrational numbers and rational numbers. This orange area is rational. Inside rational, there's integer, there's whole numbers, and there's natural numbers. Example, classify the following numbers. Then -4 is integer. This makes it rational. 2.45, 45, 45 repeating. These 3 dots means 45 is repeating. This makes it rational. This one, 15.121221222 goes on forever. This looks like a repeating decimal, but it's not repeating the same thing. It's not repeating 12 forever. It's not repeating 122 forever. It's just like a pattern, but it's not repeating. And it goes forever, then it is irrational. Any decimal number that has a certain number of decimal places, like it has 2 decimal places, it's rational. If it has 3 decimal places, it's rational. No matter it's positive or negative, it is rational because it has a certain number of decimal places. Then any other thing that we can write as fraction, it's directly rational. When you see a fraction, don't go and check on calculator. If I write 22/7, I don't see a good decimal number. This looks like irrational, but it's not, because originally this is a fraction. Since it's fraction, it's rational. No need to check. This cubic root of 80 is irrational. Cubic root of any number that is not a cubic number is irrational. For example, cubic root of 27 is equal to 3. That's rational. It has no problem. But cubic root of any other number that is not cubic is irrational. For example, cubic root of 28 is irrational. Cubic root of 8 is equal to 2. That's rational. Then pause the video, try to do these on your own. Every real number represents a point on the number line. Let's see these examples. Negative 3.5 is right between negative 3 and negative 4. It's between them. Negative 2.816 repeating. We don't care about this when we use number line. Negative 2.8 is between negative 3, negative 2, and it's closer to negative 3. 3/4 is 0.75. This is obviously between 0 and 1. It's closer to 1. 1.536, we don't care about this. 1.5 is between 1 and 2. Because of this 36, it's a little bit closer to 2. 3.9 is obviously between 3 and 4, and it's closer to 4. Square root 18, in the next example we study how can we find the place of square root 18. Representing numbers on the number line, this is how we work on square root of a number that's not a perfect square number. There we go. Represent square root 2 or radical 2 on the number line. Okay, now we write 2 here. Write a number that is more than 2 and is a square number. A square number more than 2 is 4, and a square number less than 2 is 1. Now I'm going to put the radical on all the 3 numbers. Then I know radical 1 is 1, less than. Radical 2 doesn't have an exact answer. It stays radical 4 is 2. Then I know radical 2 is a number between 1 and 2, but 2 is closer to 1 than 4. We say 1, 2, 3, 4. Between 1 and 2, there is only 1 step, whilst between 2 and 4, there are 2 steps. So 2 is closer to 1. Then on number line, it's between 1 and 2, but it's closer to 1. Just like this. Represent square root 13 on the number line, then write 13. Then write 2 numbers, one more than 13. 16 is a square number and it's more than 13. 9 is another square number that's less than 13. Then we put the radical on them. Radical 16 is 4, radical 9 is 3, radical 13 is between them, but since 13 is closer to 16, then on the number line it will be closer to 4, because the 4 belongs to 16. Homework: represent radical 33 on the number line. Radical 33 is between 36, 25, so it's 5 point something. It will be around here. Operation properties of real numbers. Okay. If we have two brackets to multiply them by each other, or to remove the brackets, or in other words to expand, we multiply the first term by both terms in the other bracket. Similarly, we multiply the second term in the first bracket by both terms in the second bracket. If I try to expand this, I want to say a times 3 is 3a. A times b is ab. 2 times 3 is 6. 2 times b is 2b. These pluses are not randomly there because this is positive, this is also positive, then it makes plus between all the terms. Rearranging this, the term that contains ab in the first, then a second, b third, constant is always at the end. This rearrange is not really necessary, but it's something that if the question said simplify your answer or write in the general form, we should do this rearrange. Order of operations. If we have multiple operations in a mathematical sentence or in a calculation, we should do the operations accordingly. Firstly, do the brackets, what's inside the brackets, then powers, then multiplication and division, they have the same strength. So from left to right, which one came first? We do that one first. It's not multiplication before division or division before multiplication. It's from left to right. Which one came first? We do that one first. Number 4 is addition and subtraction. We do these again because addition and subtractions, they have the same strength. From left to right, which one came first? We do that one first. It's not like addition is before subtraction. No, they have the same power, the same strength. Then from left to right, which one came first? We do that one first. Let's see an example. Evaluate 2 squared multiplied by 12 plus 8 all over 5. According to the notes before, we should do inside the bracket first. 12 plus 8 is 20. 2 power 2 is 4. So the bracket is done, the power is done. Fraction is division. Remember that every time you see fraction, it means you see division. There is no difference between them. This is as fraction, then I can do the multiplication, then I do the division. 4 times 20 is 80. 80 divided by 5 is 16. To evaluate this, firstly, I do multiplication. This is also multiplication. It's not considered as a bracket. First, I do multiplication. Negative 2 times 5 is negative 10. So I have 18 minus 10 over 3 times negative 3 is negative 9. 15 minus 9. Then 18 minus 10 is equal to 8. 15 minus 9 is equal to 6. Then 8 over 6 could be simplified to divide to 4, divide to 3. If you want to use calculator, then in the calculator, don't do all at once. Do it part by part. For example, I'm going to write 18 minus 2 times 5. This will be 8. See, when you are using calculator, do each part separately. Don't do all at once. Now I got the 8 from the numerator. Now let's do the denominator. The denominator is like this. Try to write the exact same thing in calculator. Plus 3 bracket negative 3, close the bracket. This is equal to 6. See? Now 6 over 8 is 4 over 3. And it's not necessary to always write the answer as decimal. 4 over 3 is simplest form. This is it. There are some exercise. Classify. This is rational. This is irrational. It's going forever and it's not repeating. Expand, multiply the 2 by inside. 2 times a is 2a plus 2 times b is 2b. Negative 3a plus b stays the same because a and b are different variables. We cannot add them or subtract them together. Here we should do inside the bracket first. 8 plus 2 is 10. Multiply by 3 over 2. 3 times 10 is 30. Over 2, that's 15. This one inside the bracket, 4 times 5 is 20. So I have 1 over 4 multiplied by 20. If I multiply a number by a fraction, I only multiply it by the numerator. So this will be 20 over 4, which is equal to 5. This one, multiply negative 5 by inside. That would be negative 20y squared. I don't multiply negative 5 by both terms because between them there is no plus or minus. Since there is no plus or minus between the 4 and the y squared, it's considered as one term. It's considered as one thing. Then we multiply a number by a term once, not twice. This is why the result is negative 20y squared. There's an example. This is an exercise actually. We have these two. We need to add them together. When we have fractions, we need to see if we have the common denominator. Luckily here the denominators are the same. Then we only add the numerators. This is just a. Just a, because there is no number in front of it, the coefficient is just 1. So 1a plus 0.06a. If we take a as common factor, it will be like 1 plus 0.06 a over 12. That's 1.06 a over 12. And this is what the question needs us to get. Question 10, there is power 2, there is division, there is plus, there is minus. What should I do? According to the order of operations, we should do the power first. 5 squared is 25 plus. I don't say 25 plus 8 because I have another operation that's stronger than plus, which is division. 8 divided 4 is 2 minus 2. Now I have left only plus and minus. I should do the plus first because this is on the left. 25 plus 2 is 27. Minus 2, the answer is 25. This question is quite simple, but I followed the steps in detail. So when you see a question which is a little bit more complicated, you know you should do plus before minus if the plus is on if the plus came first on the left, or if the minus came first on the left, we do the minus first. This one I have multiplication, division, multiplication, and another division, which is the fraction. From left to right, this multiplication came first. So 5 times 6 is 30. Divide 3 times 7 all over 12. Now 30 divided 3 is equal to 10 times 7 over 12. 10 times 7 is 70 over 12. 70 and 12 are divisible. We can firstly divide them by 2 to see the result. If I divide them by 2, this will be 35 over 6. Then 35 over 6 is good. Classify each number. Since 3 is not a perfect square number, this is irrational. 2 over 3 is rational because it's a fraction. A repeating decimal is rational. Pi is irrational. 36 is a perfect square number, so this will be 6 over 2, which is 3. But 6 over 2 is fraction. It's rational. Even 3, we can write it as 3 over 1, so it's rational. Fraction, rational. Fraction, rational. A number that has some decimal places is rational, but this exercise is like this. These numbers repeat forever. then it's irrational. That's question 21. Put these numbers on the number line. So 13 over 2, 13 divided 2 is 6.5. So 6.5 is between 6 and 7. 3.6 repeating is between 3 and 4, a little bit closer to 4. 1.5 is between 1 and 2, and it's exactly halfway. Pi is 3.14. 3.14 is here, it's close to 3. These are some rules. If we say a times 3b is the same as 3b times a, this is called commutative. This is associative if you change the place of the bracket for addition. This is called identity if you multiply a number by another number. Usually if you multiply a number by the reciprocal, the result is 1. This is called identity. If we add any number to the negative of itself, the result is 0. It's called opposite and inverse. And if I multiply this a by inside, it will be ax squared plus ax. This is distributive because the a got distributed equally for the x squared and the x. Evaluate each expression by using calculator. The question says use calculator. Then using your scientific calculator, how can you write this? You're gonna write, I'm writing the way that you enter this into calculator. I don't write the result. You can get the result. You're gonna write this in calculator like 3 times 2. You either press the square button, there's a square button in your calculator, it has the same square button, or you can use this icon 2. This means 2 power 2 plus 3. When you press the equal, you get the answer. Actually, the answer is 4 times 3, 12 plus 3, 15. To write this in calculator, firstly you write 2 power 2, then bracket 2 plus 3 plus 5. Then you'll get the answer. Similarly, this will be 2 power 2 plus 2, which is equal to 2 power 2 is 4 plus 2 is 6. To write this in calculator, 8 minus 2 is 6. 6 divided 3 is 2. Then 2 plus 1 is 3. The result is 5. Can a number be rational and irrational? The answer is no, because a number cannot be rational and irrational at the same time. This means a number cannot be fraction and not fraction at the same time. So it's not true. The answer is no. Can you represent pi on number line? Of course, we already did. It's a number between 3 and 4. This is the end of this session. Section 1.1 finished. Thank you so much for watching. Stay tuned to see the other videos. Graphic solutions